And start recording. Okay, so we haven't done this for like 2 weeks, so we have this thing. We're drawing lines, and what we want to do now is use our transform that we made last time to actually try and use it as a camera. So that's more or less the plan to begin with. And once we have like a camera implemented, it's going to be fairly straightforward to do things like, once we have it running and we have a camera going around, we can like click and place lines and move the camera around and zoom in and all that fun stuff. So there's a certain element of revision in what I want to go through. So, and also in sort of just raw coding practice. So basically, I had notes for this and I want to make sure I have them up. Basically, the plan is to hand the sort of reins over to you, and
Bad plan.
basically you're going to be driving, and what we want to do is basically make a camera that we can pan around with the mouse, and sort of the goal as far as coding it is going to be try and do it as sort of quickly and as lightweight as possible. So no classes or anything. We're gonna like be minimalist with like how much data we use and stuff. But before we get that started, there is one thing that I'm just going to sort of punt you in the right direction with, and that is we want to add a property to our transform 2D. Just because it's going to come in handy, and that is we want a property that is public matrix as X and A matrix. Yeah. So that's what we want, because we're going to want to be able to pass our transform into X and A methods that take a 4x4 matrix, which is this one with the all this stuff that we had a look at the other day. And also, for people watching at home, we should probably note that theirs is numbering is 1 based, whereas ours is 0 based. So
mine will certainly not be 0 based very soon.
Oh, you're going to change it? All right, well, we'll change that.
Yeah,
so,
my brain isn't going to be able to do that on the fly. That's like the kind of day I'm having. So
that's not a problem.
I'm just going to give it to it the way it should be.
Okay, so what I'm going to do is I'm going to say, right, even though your brain is slightly fried, I'm going to basically hand over to you and say, tell me what you would do for this matrix.
Well, I'm kind of doing it right now. I'm just everywhere.
Okay. So
everywhere I couldn't come up with a value, I kind of want to identity it, and then the ones that I do have, I wanted to fill in.
Okay. Well,
that's how I'm feeling right now.
That's okay. Well, that's exactly what you want to do. But if I can draw your attention to, if we're going to make an identity matrix, so first of all, take a look at what ours is, and then
right.
Yeah. So
I forgot.
That's fine.
It's not all ones all the way down. It's going to be one. Diagonal one's 1, 1, 1. Yeah. All right. Well, as long as this has a reasonable one.
It sounds like you've pretty much got it. So, let's see if I can fix that. So,
is this? I forget. Sorry. Is this row major or column major? It's a silly thing.
It is the same as ours. So, and like because we're using F and A, you can actually F12 and you can look at it and look at the summary. So the first row and the first column, and then the first row. So the second column. So the second value is the x. Sorry, no. The second value is the column, which represents the y. When we treat these as basis vectors. So, and I will recommend that you do the same result thing that we were doing before.
Yeah, fair enough. Yeah, that makes a lot of sense.
You do save some time by newing it up here. So,
yep. This will be super boring. This bit is going to be more fun.
It'll take a few seconds just to slap in this code.
So
M13.
Oh, I know what I'm going to do. Well, I'm going to cheat. I'm going to put off.
So let's, while you're doing that, I'm just going to draw in what we have. We've got our, that's our, oh dear, what happened? And translate spelled correctly. So, so they're like the values we're pulling from the transform.
I forgot the x1. Yeah, so that would be m14 is equal to x.
So you'll notice that that those would be the basis vectors. If we were using v3, and then obviously that would be our v3 transform as well. But because we're 2D, we need to make sure we expand it out. But that is still our transform, because when xna or fna passes in a vector to the transform, it expands it out. So x comma y becomes x comma y comma 0 comma 1 would be the v4 that passes in to do the full transform. So that should be fairly straightforward. So you're missing two values. So oh no, you're not. You did identity there, which
like I said, I was cheating. I was gonna cheat this time because again, brain.
Yep.
So I was like, well, the identity matrix will be there. I don't have to go hunting for the right coordinates for it.
I will point out that you have the indexes there. Is that right?
Well, I thought it was row and then column. So row 1.
So, yeah. So what you what you
oh
yeah. You see it. So x.
Yeah. Okay.
So that should be fine. So let's basically make this into our camera. And so if we come up to the draw method, what we can do is we can pass that into sprite batch begin now because we have it as an XNA matrix. So okay, so let's just run that and see if it.
I was passing in bar.
Yeah. I'm just testing it with the identity. Make sure nothing is broken.
Okay. Oops. I don't think mine is.
Oh, yours is a
static.
method.
Yeah, and it's also not static.
Yeah, it's not. Yeah, that's all right. Easy fixed. Scroll down to my code. At some point, we should probably resync this whole file.
I think I'm good now.
Yep, that should work. So if you run that,
Yep, same old.
okay. So at this point, now we have that working, and we have that property, and we know sort of the maths behind doing that. So yeah, I'm going to hand it over to you, and I'm going to follow along with what you're doing, and I'm going to stick my oar in every couple of minutes if there's anything interesting happens. But it's now you're driving the show. Let's make a camera that can pan around the screen. So
I brought this on myself.
try and do it in like small steps and stuff, but it should be fairly straightforward.
Yeah. Well, we're gonna need input, right? So, I want to probably grab keyboard state for now from the internet or from XML. Wait, I forget how to do this. Hold on. No. It's like get state. Input, perhaps.
Yeah. Input was our thing on River City.
Oh yeah.
Input is nice. Input is nice, and at some point maybe we just copy a version of input.
Yeah, probably.
Like mine or the River City one, because it's slightly nicer. But we can do this with just keyboard for now, or if you do mouse if you're so inclined. But
nah, this is fine.
Yep.
This is because this isn't really the issue here, so I don't want to wrap. Well, then what? Let me think. So, what are we looking for here? So every update, okay. So how about this? I'm gonna move this guy to up here. I want to store the current state of the camera. We don't really have mutation on this.
So, like, I can see where you're thinking of going, and that is a valid way of doing it. But in the future, we're going to be like zooming the camera. Maybe we're rotating the camera and stuff. And so,
all right,
it might be wise to regenerate the camera every frame, like the matrix every frame.
That makes sense.
Because
right. Okay. Sorry, go ahead.
I was going to say, like, okay, so if we're zooming it, which is what we'll eventually want to do, and you directly modify the camera, like you say, okay, let's scale the matrix by half every time we like click the scroll wheel or something, it would be possible to get into a state where, like, because you're doing that accumulation in the matrix for the camera, you could introduce floating point error, for example. There's a couple of other reasons why you want to avoid that. Like maybe you want to do things in a different order, for example. Like maybe you want to translate and then scale, or you want to scale and translate, and somewhere you might want to rotate in there. And if you have like scale, rotate, translate is what you want your camera to do, and you want to change just the rotation, you can't really easily do that if you've only got the matrix, only got the transform.
That makes sense. Yeah, basically we want to pass instructions into the state in order to build the matrix.
Exactly. So,
well, eventually I'll use the mouse state on the wheel. Although my brain is very RCRU oriented, and I know that we were like just using window client events for the zoom.
Oh no, no, we actually had we were tracking the scroll wheel. But yeah, the scroll wheel value is a pain in the ass because
it's going to be some kind of mod.
Yeah, you can do it as some kind of mod, but that gets really hairy because it's
also up. It is. Sorry. I didn't mean to.
No, it's all right. We'll
No, we're going with alt up.
Okay.
That's what we're doing. Yeah. I'm looking for my modifiers. Everything is.
Yeah.
For me
It's
All right, so this should be good enough. I don't know this plane. Okay, so now
That's all right. We can build on this. So this is just a test.
yeah. Well, yeah. I guess I want to get rid of a lot of the noise here, and just do. So we've got there.
That's all right. We wanted like a scene to scroll around. So.
Oh, right. Okay. Yeah. Right. Yeah. That's right. I'm conflating transform with.
Yeah. Grab these.
These are the bars.
Grab this nonsense and just like shove it down there. It's like that's all.
Scene stuff.
So this is what we're working on right now, and that's just it's a camera,
right.
And we're passing it into. In fact, we don't really even care about that. It's just like this is what we're working on, just this.
Right. Okay. Oops. No. So camera. Well, we're going to uniformly scale this, I'm assuming, so this is probably going to need both axes. I mean, I'm doing it, I'm only using an integer, so I'm not exactly giving myself... Well, that's fine. This is all fine.
Well, I was thinking we'd do translation first, but we can do some interesting stuff with scale, so we'll do scale first, and then we'll look at translation.
We're doing scale first because my brain is okay with that right now.
That's fine.
Oh, I actually scaled this the last time. I can't remember what it was. The original scale was, I think, transform 3D.
Oh, that was foo in my version of the code. It's just was the matrix passed into that particular line.
Okay, yeah. Just create scale. I'm just gonna copy it off yours. Transform. Create translate. So yeah, translation will be next because that's obviously straightforward too.
Oh, I see. Yeah,
Yeah, fair enough.
You got rid of your foo line. That's fine. Okay.
Fine.
No. I'm just like, what's...
It's foo now. It's too late. It's already foo. It's already foo. Oh, data. Oh, because it's moving. Oh, that's fair. Okay, that'll be interesting. Okay, I still got another compiler error here. Or just I didn't finish the thought. All right, well, we don't need to worry about that right now. I think I could run it, but I'll run it. I'm just gonna
run it and see what happens.
Yeah, and then I'll throw it. Then we'll do the translation thing. All right. So was it all up?
Awesome. Okay. So.
Oh yeah. Well, I have to hold. I didn't. It's really fast.
Oh. Neat.
Because it's not doing the went down thing. I don't have a went down.
Yeah.
Yet another utility method that I don't have.
Yeah. Well.
To like do state checking and all that.
Okay. Well,
I could add it. I mean, it depends. It depends on how much time we want to mess around with niceties. But
let's make sure we have the niceties. So we know that our camera is working and we can zoom it round. So that's the important bit. Why don't we try and get this mouse state working? Because this is actually not too hard.
Okay. It's a useful trick to have on your tools.
The thing about the mouse state is if you look scroll wheel value, and it should be documented, returns a cumulative scroll wheel value since the game starts. So
it's like elapsed time. Okay.
Basically, yeah, it's like where the scroll wheel has moved. So what we want to actually do is, well, first of all, we almost always want state last.
Yeah, that's going to give us our lengths. Same with keyboard, right?
And then what we can do is we can say So yep. So yeah, and I'll just come in and do the keyboard as well, seeing as we have that. So this should all be fairly sort of like straightforward. So what happens is, sorry, I have this backwards. So hopefully that makes sense. And so we're taking whatever the value is in the new version minus whatever it was in the old version. So that's how much it changed by, and we're adding it to this scroll pending. Now the other thing we know about scroll wheel value, and this is sort of a artifact of, I think, Win32's API and however mouse scrolling is handled, and that is clicks on the scroll wheel happen at the value of 120. So this is basically like an accumulator that can go up or down. And I guess the easiest way to explain it is just to slap it in. It's like if scroll wheel pending is greater than or equal to 120, and so if it's greater than 120, it's less than 120, we actually want to like consume that amount. So so obviously it will only trigger once. So those two comments here are our points. So that's just API bollocks. So I can give you that. So now we have this. So back to you. I'm going to follow along, and we can just make this zoom.
Oh, I see. Sure. Yeah, I'll just do this after. In fact, I'm not going to bother with this cycling thing anymore because we have this scroll wheel, so I'll just say it is less, I don't know, 4.
Okay.
Oops. Whee.
So this looks pretty good.
Nothing.
So?
Oh, mine isn't doing it.
Oh, yours is not doing it?
Mine is not doing it.
Okay, well, let me look at your code. You have a if greater than, where you should have a if less than on... No?
Oh, whoops.
Sorry, that was my mistake. Other way, perhaps? Because mine worked. I'm just like, if less than or equal to -1 plus minus.
Yeah, I think we're good now.
That looks fine.
I just did. Yeah, I just had it was reverse. Whee. Yeah. Okay.
Okay.
So we have our 4 zoom levels. Okay, good enough.
So, let's talk a little bit about what value we might actually stick in zoom. So, we've got the clicking going, which is actually really quite handy. But if we wanted to do a zoom, like we might want to, like, in fact, simple enough. Here's this canvas thing. We've got the zoom value here, and we're going 100%, and then 150, 200, 300, 400, 550, 800, blah 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 blah, and we can go out as well, like 2/3, half, 1/3, 25%. So we could set up a thing like that that's hard coded, but there is actually a sort of nice-ish way we can do it. So if we think about, like, we want zoom values of 100% and 200% and 50%, and then maybe 25% and like 400%. This sort of progression should look sort of fairly familiar. Like you'll notice that we're doubling it when we go this way, and when we go the other way it's half. Make sense?
Yep.
So, and this is, I guess, a bit of maths, but that's fine. So, I mean, do you know already sort of what mathematical operator we could use to make this progression happen?
Modulo?
Nope. Because that's more like, modulo is like a circle, and it's like, we tick around, and when we get back to the start, we loop around from 0 again.
Well, what is the range on the scroll wheel value? I guess it's not relevant, but I mean, I could just multiply and divide it.
Well, we could keep going forever. We could go like 12.5% and 800% and so on. So that's fine. Like I was just interested to know if you actually knew this ahead of time, but
I do not.
That's fine. So what we're doing is each time we're multiplying by 2. So it's like, we have 1, like, 1.0 is the amount we're scaling by. It's like times 2 times 2, and next one is times 2.
Well, yeah.
And
sorry, I thought it was.
So the thing that does that is, we've got 1, 2, 3 multiplications. So that's 2 to the n.
Right, that's power, math pow.
So math power. What's interesting is this. If we go 2 to the, well, I guess, negative n, that is equal to 1 on 2 to the n. So if we have 2 to the negative 1, that's equal to 1/2, which is 50%. And if we have 2 to the neg 2, that's equal to 1/4. Sorry, 1/4, which is 25%, and so on. And so obviously we don't need to do negative. We can just have this value here. We can go, this is zoom level 0, 1, 2, 3, neg 1, neg 2, neg 3, and so on. And obviously, in case you aren't familiar with it, 2 to the 0 equals 1. So, none of these equals 1. So let's bang that in.
Okay. Right, so I don't like, yeah, okay, cool. So I don't need to have a hard cut of max anymore. 2 to the...
So this is going to result in a floating point number.
Mm-hmm.
So we're going to want to change that, for example. Or, as we're doing with the camera here, we don't strictly need to store the value. Like the source value is the thing that we're changing. We can actually derive the output on the fly.
Yeah, I bet. Yeah, I'm just wondering, like,
Mm-hmm.
I guess it doesn't matter. Like you said, the scroll wheel is probably unbounded. Like it's just bounded by integer value, so it just is whatever up or down it was, right? It's just the number changes. So we could, yeah, what if we just pulled all this out?
Yeah.
And let the scroll be the scroll, and then when we did this, when we did the zoom itself, we would maybe blow away the zoom value and don't need it anymore, and then make the zoom value equal to the math pow to the scroll pending.
That's not a bad way of doing it, actually.
Other than now it's a double, but it needs to be a float. I gotta have to ask that guy. I'll give it a shot.
We'll see what happens. Now, what happens when you zoom?
Nothing. Yay.
Well, Well, nothing actually. Well, first of all,
Yeah.
I need to get rid of that, but I also need to get rid of this because remember that every time the scroll wheel clicks, it increments by 120. So unless you have a continuous scroll wheel, and we're resetting it. So let's just comment out those resets for now.
Yeah, I forgot that before we were doing it ourselves. Okay, well, in other words, we don't need any of that if this works.
Yeah, I mean, you may want to keep that in there just because we might do something because there's a surprise coming.
Okay, well, the surprise right now is it still doesn't work.
So, it actually does work, but I'll tell you what's happening. Because, back here we were using, n is 1 and n is 2. So we're actually doing 2 to the power of 120, which is we're either zooming in phenomenally or zooming out phenomenally. So what we could do is
we want to divide that.
We could just do that.
Yeah.
And that'll do exactly what we expect.
Sweet.
So that's actually not a bad little trick.
I wish it was smoother, but I guess...
Well, okay, so what is a nifty thing that you can do with the maths is this n here. I know my production values are so much lower today. Everything's in black. This n here does not have to be an integer. So you could do 2 to the 0.5. And that's, I'm just trying to think if I have this correct.
Well, scroll rail is an integer, so we'll have to transform. We'll have to do something to that value.
That's equal to the square root of 2, which is equal to 1.41, I think, something. So that's another way you can take it. And if you do 2 to the negative 0.5, you get like 1 on the square root of 2 equals 0.7-ish. And so what software often does is like it will use this, but it will either hard code these values here to useful numbers, or it will just pick a couple, and it's like, well, if n is equal to 0.5, it will output 1.5 instead of this 1.4 business, just because that's a bit nicer. But for at least vector graphics, this doesn't really matter so much, and certainly that's the easy way to do it. So let's bang that in now, and that should be as simple as that.
So you just doubled it so that we would get half steps, right? That's basically.
And so you'll notice that's a bit more like what you're used to in sort of your standard graphics application.
Yeah, that'll work. Cool. Yeah. All right. Well, we can probably move on to translation then.
Let's do translation.
So before I do translation, I'm going to want to do the old last keyboard went down stuff.
Yeah.
No.
No, it's like that's probably
actually.
But why don't we use the mouse?
Sorry.
Why don't we use the mouse? Because we have the last mouse and the current mouse, and that's probably a wee bit easier.
Okay. Well, when you say use the mouse, you want to basically detect a clip then? And,
yeah.
So translate to that point.
I was thinking a click and drag. And so it will look very similar to what we have here. So I'm gonna say, first of all, why don't we try just a fixed translation value first, and then we'll start worrying about putting user input on it.
Sure. Okay.
Because it's always good to be able to like see what's happening. Because otherwise, if you do like the user input first for this kind of thing, you have to basically trust that all the code you're putting in is correct. So it's better to start building something from the point where you can visualize it. So yeah, I'll let you start this off, but let's bang your translation in into this sequence.
Okay. Okay, so, well, we're going to click and drag, so I'm going to throw in a dragging, maybe, tool. And then basically just say that I'm dragging if the left button, wait, don't exactly remember that. I just say, I go, yeah, well, yeah, this will equal to.
Yes, that bollocks.
Yeah. I like hiding this stuff. Alright, so basically I'm dragging if I'm holding the button down. Okay, that's fine. And then what we want to probably have is track. Now we're instead of scroll pending, we're going to be tracking the delta left, right, up, or down of x and y. Mouse x, mouse y. I'm not sure if I need two variables here or one, but probably two. I'm not exactly sure.
Well, what I was going to say is we can get the delta the same way we got the delta here.
Oh, okay. Oh, yeah. Let me look at the data structure because it's probably like a vector or something. Scroll wheel. There's no position.
It's just x and y. Yeah.
Okay. Yeah. Okay. I'll just throw that in the vector then.
Okay.
We'll call it mouse position because that's creative. And we'll probably want to. You said, yeah, we'll get the delta the same way. So ms ms. I'm not 100% sure what this is saying. See, this isn't cumulative. This is just the horizontal position.
Yeah. So
while we're dragging, we're going to want to take away the previous position, aren't we?
Yes.
Okay. So last mouse position. Oops. This is probably going to be an issue. I can't remember if it's going to be plus or minus, but basically I want to constantly change this to what the previous movement was. This is probably wrong. I'm going to keep going. Next is...
Okay.
We want to do the translation before the scale, so I'm going to maybe... translate I feel like I'm doing something wrong because I should be maybe I'm missing a variable, but I'm not sure.
That's all right. Let's just carry on with it and see what happens. Because I'm pretty sure it will at least do something. And from
it's going to do something.
And if it does something, then we're in a position to.
Oh, okay. Well, something in the sense of nothing is something.
Yep.
I'm not sure how that happened.
Okay.
Well, what happened?
I know what's happened.
Well,
okay.
Because I moved. It's all right. I moved. I'm constantly moving, probably.
So yeah. So every frame your last mouse position is being accumulated into by not a delta but an absolute value. So
that's right. So I keep adding my mouse position, and I'm going to be gone in a couple of ticks.
Yeah. So you could just do this like for now, rather than get the delta.
Yeah. Right.
So let's just try this because I think this will actually there you go.
Whee.
So that's not too bad.
I mean. No, I mean it's not. Yeah. Oh, I forgot one silly thing.
Yeah.
It's just. I want to. I mean, I'm not used to using Oh no, this is fine. This is fine.
What are
All
you
right.
what are you not used to using?
No, I just keep getting confused. I have a lot of old, programs in my head about, well, don't do any calculation inside draw. Do the calculation of the draw outside of draw and just refer to it in draw because you shouldn't be doing any, maths inside a draw method because you can screw up your performance of your draw calls, right? But we weren't doing that here. I mean, we're kind of doing the translations, but where else are you going to do them, really? So,
Well, so the thing about that is it is something you have to think about. But that's probably not as hard and fast of a rule as that. And like what I want to what I would say about that is I'm just thinking how to explain this without going off on massive tangents. When you're drawing things, first of all, there's like a sense of code readability, and that is, we're doing a bunch of multiplications here, and we're generating a translation, and then we're doing some floating point maths to do the power, and then we're doing some more multiplication, and then we're like generating lists of sprites, and there's a lot of stuff going on in the CPU, and that's something you do want to think about, but you don't want to sort of hem yourself in and say that you can't do any calculation in your draw call, because first of all, you have to do that calculation somewhere. If you're doing that calculation in the update, you're just moving it around, and you're using more memory to like
that's right.
do it. Whereas if so just to make that a bit more concrete, what I was saying is, with the do you want to do zoom? Let's say zoom. If we're storing zoom as like is an int 32, although we're using scroll wheel pending, which is fine. That's an int 32. Whereas if you pre-calculated this in update, that would be like I'm sure spelling is really off today. Okay, that's like a transform 2D. So this is 4 bytes.
Yeah.
And this is 12 bytes? 12? I want to say 12. And at this size, it's like, that's near enough as makes no difference. But you can imagine if this was like 400 bytes or whatever, and this was like, it probably wouldn't increase linearly. If you took this approach, it might end up being 12,000 bytes, like 12K. Suddenly, like that's like a third of the level 1 cache size on the CPU. And this is like a couple of cache lines. So there's like a big difference between that. And what's happening is in your update, you're like, well, we'll access that information and then we'll write it out into that information. And then we come down to like draw, and then we have to like pull in that from probably RAM into the cache. So we're hitting RAM again for a lot more data, and then we're having to spit it out to like draw lists and stuff. Whereas if we just do stuff in draw, we're like, right, let's pull in this zoom. We've pulled in 400 bytes or 4 bytes or whatever, and then we do a whole bunch of calculations that like will take up a couple of cache lines to do, and probably hopefully sit in registers on the fly, and then we'll spit it out to these draw lists, which the GPU driver or whatever will pick up. And so if update is just touching this memory, it's going to be a whole lot faster, because this is still has to do pow and multiplication and stuff. This one still has to do pow and multiplication and stuff, but this one's doing all this storage, and it's going to be actually probably a whole lot slower.
Yeah, and this is I chose a bad example because in this case it's pretty clear that you like you're not saving generation. If there was
Yes.
a case though, if you were saving generation, and it might go flip the other way, like in terms of like
Well,
benefit.
in the case, for example, where this operation doesn't happen once per frame,
Right.
then maybe. But it's definitely something you want to think about. And you want to avoid touching data twice. So there is a case to be made that we shouldn't have draw at all. We should actually be, update should also be like generating our draw list. So we only touch that memory one time and we're doing it all at once. But that kind of gets a bit complicated, and for a bunch of like tool reasons, you want to have a draw method. So in the end, what it comes down to is what's easiest to like read. Like my handwriting,
Right.
it's really easy to read, but like read and read as like the human programmer sitting here like trying to figure out what the hell's going on. It's like, okay, I'm trying to generate my camera matrix. Here's all the code that does that in one spot, and it's easy. And then
That's right.
when things start to become a performance problem, you actually want to think about that. But almost never you want to like prematurely cache stuff. Um, and the other thing I was going to say is when we're pulling, that into memory or that into memory in this draw method, we have miles and miles of time to do maths operations. Like we can do like 40 power operators or something in the time it'll take to bring everything we're doing into memory in like a real program. So that's sort of the explanation slash rant on
No, it's cool.
on
I think it's just because I think I just have old programming in the sense, like just in my because we did do a lot of draw line sensitive stuff in the last game.
yeah. So
Because my terrible UI work was like always touching too much, addressing too much. So yeah.
yeah.
Anyway, it
So,
was a side
so
note.
you definitely got to think about how it actually is playing out, and I mean like measure it in many cases as well.
Right, of course.
So
All right.
where were we? We had this thing, and this was actually pretty good. We click, and the thing moves. So we
Yeah,
actually
there's a couple things I don't like about it. Obviously, one is that as soon as you click, it causes a translation. It'd be better if the moment you click it, the translation it's adjusted so that then nothing moves until you move.
so what I'm gonna
That's
do,
good.
and I kind of chose one path here just to sort of make sure we're all in this one case, so we can fix it all at once. And that is this last mouse position is the same as like we could change that to a property and be like get last mouse state dot x, last mouse state dot y. Like that is redundant information. That is also redundant information, and to the extent we wouldn't actually need that, we could ignore that entirely and actually go down here and replace the whole thing with like mouse.getState, and that would be mouse.getState.x, mouse.getState.y. So we actually haven't really got anywhere and haven't done any accumulation, and we can probably get rid of at least these, although we may have to add some other stuff. So that's
All your code is wrong. Goodbye.
that's fine, but like it's not so much that the code is wrong that you want to recognize, but you want to recognize that it's redundant, because I guess it does point out that it does give you some insight as to why it's wrong, as to why like nothing is like accumulating when you click and drag, but yeah,
Yeah,
it
for me,
shows.
it's just iterative. Like for me, I was just trying to get something to go, and then
Yep.
I usually do that step later. But yeah, I totally see everything you just pointed out. I mean,
Yeah.
poop.
So
Anyway, yeah,
the other thing I would say is like when I was thinking just use a fixed value, it's like just like do this, and like now we have a fixed value, or we might want we've got this if dragon, but like that is that is probably what you want to do when you're just testing some drawing stuff. Is if you can come up with just some constants just to bang in there just to test it and reason about where things should be. That's probably a better way to go before doing any input code at all. So yeah, but that's fine. So right, what do we have? I'm just going to follow along with you now. Okay, I'm following along with you, and I'm curious to see where you're going to go with this.
Oh, I'm not. I was just cleaning up my mess, feeling sheepish while I sort of thought about what to do next.
That's all right. I see what you're doing.
So I want to get back to the point where it's like, okay, so I do need to do something. I think I do need to accumulate something. I do need state.
Yes.
Because I do need to be able to kind of correct the whatever you want to call it. This is a long name. Okay. If I still think I feel like I need like a went down here because I need to do something the moment I press the button.
So
only once.
Okay, well, what I'm going to do is I'm just going to point out a thing before we get too much further, and that is that now we're not doing this business where we have like some accumulated scroll value that we're going to get rid of. This pending is probably incorrect naming because we've changed what that means. That's more like scroll state because we're just accumulating into that. We're not ever using it as like a pending thing. If you know what I mean by that.
Yeah. Like from a process point of view, we're not going to take that and do something with it. We've already done it.
Yes. Which may influence how you're going to name that one and use it. So I'll let you keep nutting that out, but I thought I'd catch that one because the way things are named is actually really important because, like I said, the hardest thing you ever do with the code is read it. So you want to help your future self and be like, let's give these things like meaningful names.
Yeah, that makes a lot of sense. Okay, so I still have to figure this. Maybe I'm doing something that could be done later, but I know that when I press the button, that's the only time I want to initialize the value of the state, because I need to delta it against the time I press down, and not keep overriding it. So I do need to check if I don't know how to exactly. Oh, I know. Okay, if ms left button equal to pressed and last mouse state left button is not equal to pressed, then this is I'm doing a click detection. And I'm going to say, okay, I'm going to initialize my mouse state to ms x ms y, and get rid of the brackets because my brain can't do that anymore. And then, okay, so that's my mouse state. And then as I'm moving now, I want to, okay, so I'm going to just bar this out for a second here.
Mm-hmm.
I don't know, this is pedantic as heck, but I just write down. I want to say if dragging and not went down. Wait, how about this? State. This equals. I want a delta between what equals the No, no. What am I trying to do here? When I'm dragging it, I want just to record the deltas, but maybe this is something I'm doing in draw.
Well, I'll just point out that you can get a delta using this mechanism here. So,
yeah,
I can even draw that out because it is the case that if give me a new layer. Okay, so if we have, those are our axes, and it's like, well, the mouse was here on one frame and here on frame 2, and we can subtract that. So this is the last frame and this is the current frame. So if we subtract, what's that, last from current minus last is equal to the delta. And so, that would be this vector here is the delta. And you can prove that is the case because then you rearrange that and it becomes, last plus delta equals current. So hopefully that makes sense.
Yeah, if not, I think that's video 1. Hopefully I'm still there.
No, that's all right.
Yeah.
So it is video 1, and so the thing is, now we can apply that to a case where we have this is frame 2 and this is frame 1 and this is the delta between those two frames.
Mm-hmm.
So it's sort of practical application of that. And it
I missed it entirely.
It helps to be able to visualize how that works. So let me catch up to you a bit. Okay, so how are you feeling about this code? Shall we run it and see what it does?
Yeah. Oh boy. Okay. It's not.
Oh, I think I'm still using the old thing.
All right. So my accumulation method is still jump.
So let's have a little think about what we're drawing. So first of all, let's think about
actually accumulate it. Go ahead.
I will say you have to be careful with this because it's like that plus itself minus something is sort of an odd thing to do.
Yeah, no, I got it wrong. Well, no, because I wanted. Yeah.
It's an odd thing to do.
Yeah.
So you've put yourself in an odd spot, but we can figure that out in a moment. But I want to roll down here to the draw method.
Okay.
And we're kind of getting what I will say is what we want to achieve is a camera that you can drag and then put down, drag and then put down. So it will move, and then when you release the mouse button, it will stay where you put it. And this code isn't doing that. So first, why don't we try and fix the drawing code? So, what do you reckon?
I don't want any logic in there.
I mean, that looks pretty reasonable to me.
That part's easy. Now.
So.
Yeah.
When the mouse goes. Now what we need to think about is why don't we do another naming fix, because this will actually help the thing. So we have mouse state, but that's not really what we're drawing here.
No, it's the delta position.
Well, I mean, not really. Oh, I mean, it depends
Okay.
what you mean by deltaing from. But let's roll back down to the drawing code and let's have a think about what actually, like, ignoring all of the update code. What if you were making a camera? What would you call this? Like, translate by something.
Position.
That's pretty reasonable. Let's call it position.
Or maybe we'll call it camera position. Or
Even better, because I'm sure that once we have like things jumping around and stuff like that, we'll want to use the variable name position in a lot of places.
right.
So now we know what we're dealing with. We have a camera position. So let's take another stab at what we want to do on each frame to update the camera position.
Each frame. Each frame, if we're dragging, then we want to manipulate the camera position to the delta of the last position that it was. So, what am I doing? It just goes bananas stuff. Okay, hold on. So if, and it's not when, so if it went down, then we start tracking the camera position. And if it is dragging, then we want,
Well, okay.
Well, it hasn't changed. It hasn't changed. We don't want to do any changing unless it's different. Although the math should probably handle the case of there being no difference, because I'm not actually getting a delta here. That's what's happening. I'm just subtracting my camera position from my initial position. This is not a delta.
Yep, that sounds like a pretty reasonable statement. So let's try and fix that one, huh?
Yeah, yeah. So I thought I was doing this because I thought it was the last position minus the current position is equal to the delta. So if that is true, and we want to apply that to the camera position, so whatever this is going to be is the delta. And I'm just going to make it my own root. So the delta is going to be right last. You want to add the delta because that's usually what you do, but the last position minus the current position. Well, the last position is literally that. That was what it was, the last tick, and then the current position is this, I guess.
You're pretty damn close, but I will just point out if you look at the maths over here, you have those backwards.
Oh, poop.
But other than that, that looks pretty reasonable to me.
Yeah. Okay. Let's see what is wrong now.
Give that a red hot go.
Okay, I still have that thing where it's pretty good, except it's still doing that thing that I don't like, which is that it corrects itself and deltas itself.
Say it. Well, when you're holding the mouse down, it behaves pretty much as you'd want it to.
That's right.
But when you click the mouse, something goes horribly wrong. So we have exactly the code for that here. So the dragging bit seems to be right, but the went down bit seems to be wrong. So let's try and figure out why this is wrong.
Probably it's wrong because we haven't deltaed it just like the other one. But I mean, it makes the code like almost none of this matters anymore, if that's correct. Because
let's try that. It's worth an experiment.
Changing stuff and seeing what happens.
Well, that's sort of a learning exercise.
It's close.
It's closer.
I mean, there's still floating point problems, I think.
Not at this scale. At this scale, it's pretty much all in floating point range.
I guess what I'm doing actually, I think what's happening is that when I press the button, I'm actually doing a first translation against me versus nothing. That's like my click versus a previous position of nothing would produce a delta that would have some movement. So it'd be like um, no, I don't know. That's weird. That's not correct.
Well,
Because if
let's
that were true, then I would see a huge leap the closer I got to the
let's forget
bottom.
about the code for a moment. Let's think about when you click, what do you expect the camera to do? Like if you click and
I
hold,
want
just
the
straight down.
if I click and hold, I don't want anything to happen except I want to make sure that the first position that I'm starting from to start calculating deltas is like the current position, so that any future drags would be against it. And that's what I thought that I had here.
Okay.
That when I press down, now my camera position is the current position, but only one time. And now when I drag, I'll start getting good deltas.
Right. So let's
But
have a
something's happening. Yeah, it's probably
let,
Go ahead.
let's look at what we've named things here, because what you said is that you want a starting position for your delta, but what you're actually
Oh, I don't
setting
have
is
a.
the camera position.
Yeah, yeah. Right, because I figured because yeah, no, that would be yeah, because the camera position is what I'm using to actually create the translation. So I'm missing state. Yeah, okay, you got me. But now, to produce the delta,
Well, tell you what, why don't we just run this and see what happens?
well, starting position isn't used for anything. Oh, it just works. Why?
uh,
Darn it. So the went down thing is just rubbish then. I don't need
so
it.
let's have a think about why you might put that there, because I mean um, you may have seen other people's and possibly even mine dragging code, and it depends on what you're doing with it. So starting camera position, we're not actually storing a camera position, we're storing the mouse position. So let's fix our naming. Starting mouse position, and now what we have is a delta offset from where we started the mouse. So if we wanted to like draw this out, on where's my colors? On like the starting frame where we click down, I'll draw it in red. The mouse might be here. And then on like frame 2, the mouse will be here. And we have this delta there. On frame like 3, the mouse might be up here. And we have this delta from the previous mouse position like that. But we also have this delta here from the original mouse position here. So if we want to use that delta, we have to think about the maths for that. So we have to think about sorry?
We'll just hold on a sec because we don't. I mean, it works without that.
Yes.
Like
yeah. So every frame we're updating the camera position by this small delta. So this one there and this like light blue one here. Whereas if we wanted to like use the starting mouse position, we then have to maybe track like ball is down or went down or whatever.
Mm-hmm.
Or current your ball is dragging, which sort of you had. So I feel like you're like mixing in some other stuff. So when we come down to here, what we want to do is like, well, what's the current mouse position, which is this green vector here, and then on the next frame it's this vector here, and this delta is getting bigger every time. So we would want to do something like start mouse position is the current position minus the starting position. So this is the delta that's getting bigger every single frame because our position changes. Now if we run that, obviously this is not going to work because it flies off the screen because every time we're adding this massive delta. Like you can sort of see there, it's when I do it, it just kicks off. Sort of, it grows every single time. What we want to do is we want to have camera position equals starting camera position plus the change. So starting camera position, and then we have to track that as well. So starting camera position equals not the mouse position but the camera position, and then in theory this should work. And so this works as well. But obviously, like, that's a whole lot of extra stuff that you don't need to track. So we can get rid of that, and we can get rid of that, and we can get rid of that, and we can go back to what we had there, which was new vector last mouse state.x last mouse state.y, and that we can just, every frame will just add on whatever the delta was. As simple as that. And in fact, we don't even need this dragon because we only check it once. So that's like a really good exercise in trying to do everything you can to remove redundancy and state from a thing. If you like think really hard about what values are actually getting used. So, okay with this so far?
Oh yeah.
All right. Let me.
Do we have time though? I think we're kind of way over.
We may be quite a bit over. So, I think maybe we'll wrap it up there, and then I have some other stuff to do next time, which will start with a bit of maths as well. Something a bit more meaty than this thing that we started with here, which was just how to blow out the matrix. But I'll show you another bit of maths, because what you'll find when we do this, we're dragging it around and then we zoom in, and that's not working exactly as we want, because once we're applying the zoom, which I'll just show you as we can. Somehow I've got my Visual Studio into like disassembly mode after yesterday's debugging session, and
sorry.
That's all right. That's all right. So I can change that order, and now that works. But we might,
order matters always.
Order matters, but we might want a case where we're like, I want to zoom in on this yellow thing, so I'm going to put my mouse here and like zoom in.
And you want to retarget it. Yeah,
retarget the zooming. And the other thing was we want to like draw some lines while we're zoomed out. It's like I want to draw a line from there to there, so I need to work out where that is in like world space and stuff. So I think that next time we'll sort of start getting into that. So that will be quite entertaining.
Everything looks better with grid lines. So hopefully we can get some grid lines.
Oh yeah. Grid lines always good. Actually, that's a really good idea. We should do that. So the last thing I will point out is you probably want to add this in is active. Otherwise, because I just noticed I did it here. If I'm over here dragging like this around and I don't have is active on, I can start dragging it while I'm in the editor and stuff. So that's just a thing you can just kick in there. Just for.
But wouldn't you want to throw the is active at the top of your update method and bomb out?
Quite possibly. Like you might want to not update the scroll state. You probably do want to update the mouse and keyboard state, even though you're not using them. But yeah, it just depends on what you're doing. But that one's just a quick and dirty thing to do. Because the other thing with this is, this is 1, 2, 3, 4 lines of code, and you can probably just get rid of the variable. So it's like 3 lines of code. And once it's 3 lines of code, you can just slap it around and modify it as you need it. You know, and do that thing I was saying before about like compression oriented programming. That
Yeah, I wrote delta because I was just thinking it out.
yeah,
Like,
this is reasonable because it's like that's the, you know, mouse delta and stuff, and that's like maybe a useful documentation thing. So that's not a big deal. The important point is that like this is very little code, and it's only the code that's necessary. And then, you know, once you have other stuff to do, you can blow it out. And you know, maybe you're doing this calculation a whole lot, and so you might make like a little method that's like, give me the delta of this frame. Or maybe you're doing like a whole lot of drags, and you might turn this into a drag method. It's like, get me the drag amount this frame. So it's like delta or 0 if, you know, that or something.
right.
But like, just to begin with, that's brilliant. I'm just scanning through my notes here. Yeah, so I think we'll finish up there. So I'm going to stop recording.